Okay, so we're doing the ellipse. So we're in day 4. So first 2 days we were learning how to graph the ellipse. The third day we learned how to find the equation of the ellipse given important information of the ellipse, like given the center or vertices and the major axis, and then come up with the equation of the ellipse, and then find the other information. Okay. Today we're going to learn how to graph them, but also when it's given to you in this form. Okay. So this is a conic section. Okay, and I'm telling you that it's an ellipse. But on the formula sheet that I gave you at the top, it gives you kind of a list of criteria. If you see it like this in this form, expanded form, and not in its conic form, there's a way to look at it and figure out which one it is. For instance, in this one, if you look at the lead coefficients on the x squared and the y squared terms, well, if there's no x squared or there's no y squared, if there's only one of them, you know that you're dealing with a parabola. So if it's missing an x squared or a y squared, you know you're dealing with a parabola. If both of them are there, x squared and y squared, and the coefficients are the same, then you're dealing with a circle. If one of them is negative, you're dealing with a hyperbola. But since in this case they're both positive, we're dealing with an ellipse. Okay, but there's a classification chart at the top of your formula chart that kind of helps you with that. So before we can find the center and the foci and the vertices and the co-vertices and all that good stuff and graph it, we need to get this into its conic form. Okay, so we're going to be using something that we learned last week, which is completing the square. So what we're going to need to do here is we're going to complete the square on this so that we can actually get it into its conic form. Now we've completed the square on the parabola and the circle, but there's an added step when we do it with an ellipse. Okay, so here we go. We're going to complete the square. So it's just like if you complete the square on a parabola. The difference is that we're going to have to do it twice, one for the x terms and one for the y terms. Okay, so just like when we were doing with the parabola, step 1 is to group your terms. So in this problem, we're going to first group our x's. So 9x squared plus 36x plus, and we're going to group our y terms. So 4y squared minus 8y. And then I'm going to move the 40 to the other side. Okay? And then you get negative 4 over here. Okay? So basically, I moved all of my terms that didn't have x or y to the other side, and I grouped my x terms, I grouped my y terms. Now, just like completing the square before, since we have lead coefficients, before we can start completing the square, we've got to remove those coefficients. So in the x terms, I'm going to factor out 9. So factoring out 9, I get x squared plus 4x, and I'm going to need that third term. Plus, do the same thing for the y's. Factor out the 4, you get y squared minus 2y equals negative 4. Okay? Now, so we're basically following the exact same steps we did with completing the square, but we're doing it for this ellipse. Okay? So the next step, first step was grouping your terms, second step was factoring out your lead coefficient. Third step is writing it in a perfect square form like this. Okay. And you take your middle term, divide it by 2, put it here, and then square it and put that number here. So positive 4 divided by 2 is 2, 2 squared is 4. So now we got to balance our equation. Because we added this plus 4 in here, we also have to balance our equation. So we have to take 4 times the 9, which is 36. And since we added 36 to this side, we have to add 36 to the other side. Okay? Since we have an equal sign, remember what you do to one side, you do to the other side. Now we're going to do the same thing here. We're going to take negative 2 divided by 2. We get negative 1. Then we're going to square it, put it here, plus 1. And so we have 4 times 1, so we've added 4 to this side, so we also have to add 4 to the other side. Okay? So we've completed the square, and now we add up our terms on this, so negative 4 plus 4 is 0, so we end up with 36. Okay? Now, where we're at now, right here, we're almost in our conic form. Okay? There's only one problem. An ellipse should always be equal to 1. The equation should always be equal to 1. And right now I'm equal to 36. So that's what I'm going to do next. So I'm going to divide this by 36. Okay? So that it ends up being equal to 1. But that also means I have to divide this and this by 36. Okay? Because again, what you do to one side, you got to do to the other side. So now my equation is starting to look more like the ellipse equation, because now I have my denominators. And now we reduce our fractions. So we have 9 over 36, which reduces, so we get x plus 2 squared over 4, because 9 and 36 are both divisible by 9. And then y minus 1 squared, that's a y. And 4 and 36 are divisible by 4, which gives me 9. So this is my ellipse equation. X plus 2 squared over 4 plus y minus 1 squared over 9 equals 1. Okay? So now that we have our ellipse equation in its conic form, come up here. So we get x plus 2 squared over 4 plus y minus 1 squared over 9 equals 1. So now I've got it in my conic form. Now I can use that to find all information. So basically we're back to what we were doing earlier this week, which is using this equation to find our information. So this is h, and this is k. So my center is at negative 2, positive 1. Now, is this a vertical or a horizontal ellipse? Well, the bigger number's under the y. So this is a vertical ellipse. And a squared is 9, and b squared is 4, which means a is 3, b is 2, and then using that equation to find c, a squared minus b squared, square root, c is the square root of 5, because we're going to need that for the foci. So we go to our formula chart, and since we're dealing with a vertically major axis, this is the equation we use for our foci. It's h comma k plus or minus c. So it's going to be h, k plus or minus, and c is the square root of 5. The vertices, same thing. This is the vertices. It's h comma k plus or minus what a is. So it's negative 2, 1 plus or minus a, which is 3. And the co-vertices are h plus or minus b, which is 2, comma k, which is 1. So there's all our important information for our ellipse. So let's graph it. So we start with our center. Negative 2, 1, right there. That's my center. Then my vertices, which go up 1, 2, 3, since it's vertical, down 1, 2, 3. Then my co-vertices, I go left and right 2. So these are my co-vertices, this is my vertices, that's my vertices. And then my foci, which the square root of 5 is a little more than 2. So 1, 2 right here. That's my vertices, my foci. So focus. And now we draw our ellipse. That's a pretty good ellipse. Okay. For my kids, you need your code. Your code for today is T3ST1NG. T3ST1NG. And that's it. So when we're graphing these, again, what we're doing here is just one more step. We're adding a step in. So before I can graph it and do everything that we were doing a couple days ago, I just have to do one more thing, which is to complete my square first. And like I said earlier, it's not a teacher trick. We're not trying to trick you, but often as teachers, we'll teach you one concept, and then we'll ask you to do another concept before you can get to that one. So a couple days ago, we learned how to graph them. Then I've added in completing the square, which we learned last week. And now I'm asking you to complete the square before you could graph the ellipse. So it's basically just adding a step in to what it is that we're doing. Make sure, one of the hardest things about this is making sure that you are finding whether it's vertical or horizontal. I've seen lots of my students making mistakes because they're either using the wrong equations for one of them or the other. Okay? And the other one is this one, making a mistake using actual Pythagorean theorem instead of using that equation for finding C. And this equation makes sense if you think about it, because a squared is always the bigger one. There's a reason. It's so that when you find C, you never get a negative number. Because if a squared was smaller than b, then you'd get a negative number here under the radical, and you can't do that. So that's part of the reason. Okay? All right.